Okay, so we're going to begin by listing our corresponding congruent angles. So if I begin with angle J is congruent to angle N. Next, we have angle K, which is congruent to angle P. We have angle M, which is congruent to angle R. And we have angle L, which is congruent to angle Q. Do you have any questions on how we got these? Our second part then is going to be listing out those ratios of those sides to see if they are proportional.
Is that a P?
That's a P and the next one's an R. The R just looks a little rough. I'll fix it. Okay, let's try that again. R. Okay, so then we have B and we're creating those ratios. So for B, we're going to do, it's JKLM to NPQR, which means that the ones with the J's have to be on top. So I'm going to do JM. Are you okay over there? JM over NR. Notice that they're both the top sides. Now I'm going to continue moving right. So I now have ML over RQ, which is equal to LK over QP. And last but not least, I have KJ over PN. Okay, so now we've created those ratios. Are you guys okay with how we got those? So we see it's this side and we keep going on. Now we're going to substitute in the numbers that we know and create those ratios. So we have JM. What's our value for JM? So this is C. So we have JM over NR. You said it was 2.8? Yeah. 2.8 over? 4.2. Okay, when you go to your calculator, you're going to put this in and hit divide. I'll pause this. Okay, so right now we're going to do that. And now that you've hit that second PRB, that probability button, what is our fraction? Nothing happened? And we see that it is 2/3. Now we're going to go to our next one. Our next one is ML over RQ. ML is what value?
4.
Okay, and RQ is?
6.
We know that can reduce. How does it reduce? 2 over 3. 2 goes into 4 2 times. 2 goes into 3 3 times. Okay. Right here we see that we have LK over QP. This isn't our last one. We have one more. LK is what value? 2. And QP is 3. And then this is our truly last one. We have JM over, nope, KJ. La-di-da, la-di-da. KJ over NP. KJ is 2 and NP is 3. So we talked last week about scale factor, or yesterday I guess, so it wasn't last week. Yesterday about scale factor, so that's that ratio. And we see that all of them end up with the same ratio. We would say our scale factor is 2/3. Example 3, again, I'm going to write out those things. So if you give me a minute, you guys can fill them out while I fill them out. In the ratios for this one, we see that we have VW over QR, which is equal to VX over QS. And then we have WX over RS. Now that we have that, we're going to complete those fractions again with the information that we know. So we have VW over QR. VW is what amount?
10 over 15.
10 over 15. Okay, what can we take out of both of those? We take out a 5. We take a 5 out of both, and what are we left with? 2 and 3. Ooh. There's no way for me to, let's see if I can. Oh, I can. Okay, so we have 2 over 3. Next one up, we have VX over QS.
26 over
26 over 39. Okay, what goes into both of those?
I don't know. 3, 6.
So we know 3 can't go in because it's 26, not 27.
Okay.
But something else goes in.
4.
4 cannot go into 39 because it's not even.
No. 3.
I just said that.
So I said no to that.
Don't say it like
Good.
13.
So we see 13 goes into it. Yes.
Why you say it there first?
So 13 goes into 22 or 26 how many times?
2.
2 goes into 39 how many times?
3.
Okay, and our last one is WX
24 over 36.
over RS, which you just told me is 24 over 36. So we got that from the RS. See it? Okay.
So 6 over 9.
So we can do that as 6 over 9. How did you do that?
4.
Took out a 4, so you got 6 over 9.
Yes.
Then
Then took out 3.
you took out a 3.
Then 2 over 3.
So if you took out a 4 and a 3, that's like taking out a 12. So we see that 12 goes into 24 2 times. And we see that it goes into 36 3 times. So I just didn't have the space to do it your way, but you did a nice job. Okay, so with that, we see again our scale factor here is 2/3.
They all the same. You done?
So for this example, now that we have the information down, we are just going to start creating the ratios that we have. We know that these are 2 rectangles. So the 2 ratios I have is I know that there's a relationship between DC and NM. So I'm going to have DC over NM equals, and I see that it's going to be BC over LM. Now I'm going to substitute in what I know for those two. So I see that DC is what value? And I have NM, which is equal to, we see BC, which is
4
over LM, which is 6. Okay, now that we have that, we're just going to now perform that cross multiplication. 8 times 6 equals 4 times X. What was 8 times 6? Okay, I heard 2 different answers. So let's verify it.
It's 48. It's 48.
So you feel more confident with that? 48 equals 4X. Isolate, we're going to divide by 4. X equals? 4 goes into 4 one time. 4 goes into 8 2 times. It goes into it 12 times. So our last part of this answer is X equals 12, and we're done with this problem. Our next one, once again, I have to draw on there. So again, I apologize. Give me 1 second, and I will have it up. So here we know that this is 16 inches. Let's see if I can write. 16 inches. And we know that this is 12 inches. We also know all of our angles are congruent. Okay, knowing that all of our angles are congruent tells us which type of triangle is this. This is a...
It's equilateral.
So we know it's equilateral, but only because we know it's equiangular. Equiangular triangles are going to be equilateral. Okay, so using that, we want to decide what our ratio or scale factor is. So we're going to relate the 2 sides. Our 2 sides are going to be that 12 inches and our 16 inches. We now have to reduce. There's inches in both. We cancel them. What goes into 12 and to 16? 4. So 4 goes into 12 how many times?
3.
4 goes into 16 how many times? Ooh, that's a rough 3, but... Okay, now we want to see the ratio, the parameter of that picture frame. So perimeter, how do we figure out what a perimeter is? We're adding up all the sides, right? So of our smaller triangle, or the perimeter of 1, is 12 inches plus 12 inches plus 12 inches, which is how many inches?
36 inches.
36 inches. Nice job. Okay, our perimeter 2 is going to be that 16 inches. So we're going to have 16 inches
48 inches.
plus 16 inches plus 16 inches. And what did you say it was?
48 inches.
So we cannot square root in this case. I'm not sure how you would use it. So we can't, because that is area of a square. And this is a triangle. So So we have 48 down here, inches. Same units, they cancel. What goes into 12 and 12? What goes into 36 and 48? 12 goes into 46. How many? Nope. 36. How many times? 48. 3. 12 goes into 48. Okay. And what did we notice?
They both the same. So
They're both the same. Okay. Is it okay if I switch the slide already?
we can slide to what are we doing now?
You needed another second, Malik? All right. I don't mind going back if you needed it. Okay. So our last one is our theorem. So what we used in that one is we see if two polygons are similar, then the ratio of their perimeters are equal to the ratio of the corresponding side lengths.